Hi everyone, so today we will be solving LeetCode 852. It's called peak index in a mountain array. So in this question, we are given an array of length n where values increase to a peak and then they decrease. So we need to just return the index of a peak element and we need to solve this in log n time. So as soon as we see log n time, we get the hint of binary search. So you would be solving this using binary search. So let me first explain you the question. So our array would be first increasing and then at some point the nature changes, that is it becomes decreasing later on. So we need to return the index of this transition point or our peak element. Suppose, let's see our example. So we have 0, 10, 5 and 2. So as you can see, let me write it here. So it's 0, 10, 5 and 2. So as you can see here, from 0 to 10 we increased, but from this onwards we start decreasing. So our transition point or our peak element becomes 10. So we need to just return its index, which is nothing but 1. So we output 1 in our example. So I hope the question is clear. So let's see how we would be solving this. So I have taken another example. So as you can see in this, from 0 till 12, we got increasing nature, but from here, we get decreasing nature. So that means our transition point or peak element becomes 12. And we simply return its index, which is nothing but 3. So 3 would be output of this case. So let's head over to the approach of solving this. So since our array is sorted, I know it's not completely sorted, but it's sorted in parts. The first part is sorted in increasing order, and then the second part is sorted in decreasing order. So we would be utilizing binary search for this. So as we know in binary search what we do, let me first again copy the array. So it's 0, 8, 10, 12, 9, 3 and 1. And let me index it as well. Perfect. So as you know, in binary search, we take two indices known as starting index and ending index. Ending index will be the last index, which is 6 in this case, n minus 1. So we know in binary search, every time we would compute a middle value, middle index, which is nothing but the average of the starting and ending index. And we just make our decisions based on the value or the element present at the mid index. So that's all we would do in this also. So let me initialize it. So starting index is 1, 0 and index is 1. So let's discuss our scenarios. So what can be the possible scenarios? Suppose we are here. Let's say we are at 8. Suppose our mid points to 8. So if our mid is 8, then mid plus 1 will be pointing to 10. So in this case, our array of mid, that is the value present at the middle index, is less than its successor, that is the value present at mid plus 1. So this means the previous value is lesser than the next value, and which means we are still in the increasing portion because in increasing only now the previous is smaller than the large next value. So we are sure that in this case we are in the increasing part of our array. And as I told you, the peak would be in the middle of increasing and decreasing portions. So as we are in the increasing part, we are sure that our peak element would be somewhere to the right. So we can simply ignore this left portion entirely. So I hope the point is clear. So if our middle value is less than middle plus 1, that means we are still in our increasing portion. That means we are sure that our peak element would definitely be towards right only. because we are still in the increasing portion and peak is something which is where the increasing portion stops. But we are still in increasing portion because this means we haven't reached our peak yet and it is somewhere in the right. So in this case, we would simply do starting is equal to mid plus 1. So this will exclude all the left portion. So I hope this is clear. And coming to the else case, if this is not true, that means our mid value was larger than mid plus 1. So let me take that case as well. Suppose, let's say our mid is here. So mid plus 1 would be here, right? So in this case, mid is greater than mid plus 1. So we are currently at the decreasing portion because in decreasing only the first element is larger than the next element. So we are in the decreasing portion. But so we are sure since we are decreasing portion, we would reduce our, that means we would exclude our right portion now because peak is something which is the start of the decreasing portion. So if we are at decreasing portion, it would be somewhere at the left, as you can see in the diagram also. So if our mid value is larger than mid plus 1, we are sure that our peak element would be somewhere on the left. So we would decrease our ending index to mid minus 1. So what will this do? This will exclude all the right portion because suppose our starting index was this, ending index was this, mid was this. So if I'm saying ending index becomes mid minus 1, that means ending index now becomes this. That means we excluded this right portion. And now we consider this as our range. So that's why I wrote ending is equal to mid minus 1. But here's a catch. Suppose, let me first clean this up. Yeah, perfect. But suppose if our mid is here, mid points to 12, so that means mid plus 1 would point to 9. Now in this case, here also mid is greater than mid plus 1. That means we are in the decreasing portion. So we would say that since we are decreasing portion, let's do ending index equal to mid minus 1. So if mid was there, we would point ending index to this. And our range becomes this, or wherever the starting index is. But you would observe that we did a mistake. Our peak element was 12, but we excluded that from our range only. So here's a catch that if this case arises, the mid value can also be the answer or the peak element. So we would consider that also in our range. So what I'm saying is, suppose we are in decreasing portion. So we cannot say, right, that we are in the starting of the decreasing portion or in the middle, somewhere in the middle. If we are in the middle, then we are sure that we would exclude the right portion and we would do ending index equal to mid minus 1. But if we are at the starting of the decreasing portion, that means we are at the peak element. So we cannot exclude this because that's only our answer. So in this case, what we will do, we would not ending index, we will not point it to mid minus 1, rather we would point it to mid only. So we would exclude this minus 1. So now what we will do is, we would, if any time we arrive at this case, where our mid value is greater than mid plus 1, like in this case also. Our mid was this and mid plus 1 was this. So we say that since our mid value is greater than mid plus 1, so let's not exclude this part. Let's we would exclude this part, but let's consider this mid as also. And let's not directly jump to mid minus 1. Rather, let's point our ending index to mid only and not mid minus 1 because mid can also be our answer. So I hope this point is clear. So that's why we would write ending index equal to mid and not mid minus 1. So I hope this is clear. So this was the entire crux of the problem. And uh, we would out, as you know, in the outer condition, we put something like this. So our runs until these condition holds true. And as soon as we break out of it, that means our starting and index converge. And the algorithm will run in such a way that it will always converge at the peak index only. So at the end, we would return nothing but our starting index. Or alternatively, ending index also we can return. Any one of the above. So this was the entire approach. So I hope this point is clear. The main point was this one, that suppose we are at the decreasing portion, that is, our mid is greater than mid plus 1. So we would definitely exclude the right portion, but we would consider this mid also, because it may be the case, like here also, that this can also be a peak element. So that's why we would not exclude that from our range. We would still do ending index equal to mid and not mid minus 1, because that can also be a peak element. So that's the algorithm. Now let me write the code for it. Then things will become much more clearer. So I've written the code for you. So we would have a get in peak index function, which would return our index of the peak element, and it takes an integer array as an argument. So we take two variables, starting index and ending index, and we run this while loop. Every time we compute our middle index, and if the value present at our middle index is less than the value present at the middle plus 1, that means we are in the increasing portion. So if we are increasing portion, we do nothing but exclude the left portion. So that means we do starting index equal to mid plus 1. Otherwise, we are in the decreasing portion. So in decreasing portion, we are sure that middle will be in the left. So we